Hello, today we're going to have a look at solving simultaneous equations by using the substitution method. Now let's recall that if two straight lines have different gradients, they are therefore not parallel and they will have a point of intersection. Today we're going to be specifically looking at linear relationships, so straight lines. So straight lines will only have one point of intersection. Okay, let's have a look at some examples. So the first example here, question A, so it says solve the following pairs of simultaneous equations using the substitution method. So the very first thing that we do is, well, I've got these two equations here. I need to find where these two straight lines will intersect. The first part of the substitution method is labeling our questions. I'm going to call the equation y equals x plus 4 equation 1. X plus y will be equation 2. Now, the whole point of the substitution method is that we have one of the variables, okay, either x or y or whatever they may be, as the subject of the equation. Now, the subject of the equation is when it's by itself on one side. So here I've got y by itself on one side. Now, therefore, from equation 1, I could say that y is actually x plus 4. So in the second equation, x plus y equals 6, I'm going to replace the y down here in equation 2 with the x plus 4. So here I'm going to write sub, or you could write substitute, okay? Equation 1 into 2. Okay, it's very important that you write that line, okay, because we need to be able to follow your thinking, and also you'll need to go back and check that you actually have a good lines of logic. So I said that I was going to replace the y in the second equation, okay, with the x plus 4. So here I'm going to have x plus, okay, and instead of the y, I'm going to have x plus 4. Okay, it's good practice to have those brackets around in case there was a number out here, say 2 or something like that, equals 6. Now, the number out here is actually 1, okay, because it's 1y, but we don't need to write that. So, simplifying this, okay, so I'm going to have 2x plus 4 is equal to 6. I'm going to subtract 4 to both sides, so I'll have 2x is equal to 2, dividing each by 2, and I'll get an x value of 1. Now that's my x coordinate, okay, of the point of intersection. Now I also need a y coordinate for my point of intersection. It's important that you highlight this, okay, the x equals 1, because you will need to refer back to it. So here, I'm now going to actually put this x equals 1, okay, into one of these equations, okay, because I'll get the same y coordinate because it's the same point where they cross. So here, I need to ask myself, well, which one would be easier to find y, okay? So here, if I sub x in here, I've already got y as the subject, so that's going to be the best option here. You could substitute it into either and solve for y and you'll get the same answer. So it doesn't really matter, but sometimes you can make your life a little bit easier if you think a bit ahead. So I'm going to substitute x equal 1 into equation 1. So now I have y is equal to, and instead of writing x, I'll write 1, okay, plus 4. Okay, I should have brackets there. So therefore, y is equal to 5. Now, I'm almost done, okay? I need to actually make sure that I write it as a pair of coordinates because this is a point on the Cartesian plane. So, therefore, the point of intersection is 1, 5. Okay, that's my solution. Let's go and actually check this graphically. So, down below, here we go. The blue line here, okay, has a positive gradient, so that's actually going to be equation 1. okay? And this one here will be equation 2. Now, I actually said that the point of intersection, and I found it through the substitution method, as 1, 5. So let's check that. Okay, so 1's here, 5's here. Okay, so let's just plot this here. Is this point here the coordinates 1, 5? Yes, it is. Okay, fantastic. We did that well. Let's now have a look at a second example. In question B here, I've got 3x plus y equals 5 and x plus y equals 1. First thing we do, let's label these equations. Equation 1 and equation 2. Now, I did say in the first example that I actually need to make one of the variables, either x or y, the subject in one. That is my first step after labeling the questions. So I could either change this one to get x or y by itself, or this one to get x or y by itself. Now, which equation looks a little bit simpler? The second one. So I might just subtract x to both sides to that equation 2. So I'm going to change it. So I'm just going to go subtract x. So then I get y is equal to 1 minus x. Now, I manipulated equation 2, okay? So I'm actually going to now call this 2a because it's part of the family of the second equation, okay? It just helps with what we're going to do next. Now, for this one here, so I'm going to now substitute 2a, and you've got to substitute it into the other one, okay? So I'm going to put the y value of 1 minus x where y is here, okay? So I'm going to do that now. So I'm going to substitute 2a into 1, okay? So that's substituting 1 minus x where y is. So I have, therefore, I'm rewriting equation 1 now. So I have 3x plus, now I said it was y, but instead of y, I'm writing the 1 minus x, okay? And this is equal to 5. Now, all I need to do at this point is solve this equation, okay? So I've got 3x and a minus x, so that's 2x, plus 1 is equal to 5, subtract 1, so I get 2x is equal to 4, divide by 2, so x would equal to 2. So my x-coordinate of my point of intersection is 2. Now I need to find the y-coordinate of this point. Now, we're going to substitute x equals 2 into one of the equations above. Now, we need to look at these three equations here and ask ourselves, well, what is the best or easiest way to actually find y? I could substitute x equals 2 into any of those three and still get the same answer, but sometimes, as I said before, you can make your life a little bit easier. So if you have the other variable, the one that you don't have, I don't have y here, if that is the subject in one of the three equations, substitute into that one, okay? So here, I'm now going to go y equals to 1. Oh, sorry, I should write. I'm substituting this into 2a here. So I'm going to 2a. So y equals 1 minus, okay, and then I said x, but x here is 2. So y equals 2 minus 1. So the coordinates of this point of intersection is actually going to be 2, negative 1. Now let's test that. Okay, let's check that in our answer. So I said 2, negative 1. Okay. Here are the two lines that I put onto the Cartesian plane earlier. The point of intersection is here. And that point there is 2. And it's also down 1, negative 1. Fantastic. Alright, so that's how you can use the substitution method. There's a few steps. Okay. 1, label your questions. 2, make sure that you have one as one of the variables as the subject of the equation, and then substitute into the other and solve the equations. Fantastic.